Hello, hi. So this is for the further maths flashback, November 3. This is question number 1. So we're going to prove, this is a sum of series, so we're going to have to prove that the sum of r minus 1 r plus 2 is equal to 1/3 n minus 1 n plus 4. So if we expand the left hand side, and I'm going to split it up into its different terms. So when I expand the brackets, I'm going to get r squared plus r minus 2. So I'm going to do the sum of r squared plus the sum of r plus the sum of minus 2. And the sum of r squared, well, that's 1/6, and this can be found in the formula. Oh, no. 1/6 n plus 1, 2n plus 1, plus the sum of r. This isn't in the formula book, and so you're going to need to know that the sum of r is a half of n plus 1, and the sum of minus 2, n times, so it's going to be minus 2 times n. A key thing with these things is you should not be trying to expand, and you shouldn't ever really get a cubic. So in the very, very rare occasions you might get a cubic, just because there's nothing you can factorize, but you should be looking to factorize, so we can see that there's an n in each of these three terms. And then you should always try and take out the lowest number. So in this case, that's 1/6. So I'm going to take out 1/6, and as I said, n is common. So from the first term, if I take out 1/6 n, I'm left with an n plus 1 and a 2n plus 1. Now if I take 1/6 out of a half, so 1/6 times what gives me a half? Well, 1/6 times 3 will give me a half. I've taken the n out, so I've got 3 times n plus 1. And a similar philosophy, so 1/6 times what will give me 2. 1/6 times by 12 will give me 2. There's a minus there, and then the n came out. And if now we can expand it, and having a quadratic is a lot nicer than having a cubic. So when I expand this, I'm going to get 2n squared plus 3n plus 1 plus 3n plus 3 minus 12. And that, if I simplify that, gives me 2n squared plus 6n minus 8. That's 1/6 n 2 brackets n squared plus 3n minus 4. And now I'm going to take this 2 outside, and so it's going to be 1/6 times 2. It's 2/6, which is 1/3 n, and then I'm going to factorize the brackets on the inside, and so that's going to be n plus 4 n minus 1. And that is what we wanted, so that's the end of my proof. Yeah.